Okay. Real quick, how would we find the slope? All I want to do is find the slope.
Number 26.
This is going to be a little different. I'm just going to write this one down. Okay, that's it. Now, if the equation, if the line is written in slope-intercept form, it's easy, right? It's just whatever m is, mx plus b is whatever being multiplied by x. We looked at that the other day. That's easy. What about something like this where the line is written in standard form? You can't just look at it and see the slope.
You gotta get y by itself.
You gotta get y by itself. And now watch this process of getting y by itself. If all I'm trying to do is find the slope, if that's all I care about, I could take some shortcuts. Right? If I want to get y by itself, what are the 2 steps in order I've got to do to get the y by itself?
Divide by 5.
Well, but I got to do them in order.
Always.
What do I do first? I always add or subtract first when I'm isolated, right? So what am I going to do?
Subtract 2x.
Subtract 2x, right? So we'll subtract 2x, and what's that going to give us then? We're going to end up getting, on this side, we're going to get negative 5y equals, now let's put the x term first, right?
Negative.
We're going to get negative 2x plus 7. I don't even really care about the 7, though, because my next step is going to be to divide both sides by negative 5, right? Okay, so if I divide both sides by negative 5, and we talked about this the other day, if I divide the right side, which has 2 terms in this case, more than 1 term, when I divide the right side by negative 5, it's like dividing each term by negative 5, right? So I'm going to have a negative 5 there and a negative 5 there. But look what I end up with. Y equals, what's negative 2 over negative 5? Well,
2/5.
2/5, right? So I get 2/5 x plus, who cares?
Found the slope.
Right, because all I'm looking for is the slope, right? See what I'm saying? So you can almost just do this in your head if you think about it. If I'm going to get the y by itself, I could see here that, okay, I'm going to subtract the 2x to this side. All I care about is the x term, and then divide by negative 5, so I'm going to get negative 2 over negative 5, 2/5. See what I'm saying? You could just about, if you practice just a little bit, you could just do that in your head and say, okay, I can look at that, do those couple steps in my head, and I know I'm going to get 2/5, right? Okay, we'll come back to that. Okay, let's write an equation in slope-intercept form for the line that passes through this point parallel to this other line. So let's review real quick. What does it mean? How are slopes related for parallel and perpendicular lines? If 2 lines are parallel, train tracks, right?
Yeah, like
What do you know about their slopes? Right, so it'd be like this, or so you gotta be the same, because they're slanted the same, aren't they? That both lines have to rise and run the same amount so that they never cross. Okay, that makes sense. Parallel lines have equal slopes. The one that's a little tougher to remember is, what if they're perpendicular? How are the slopes of perpendicular lines related? They're opposite. There's 2 things. They're opposite, and what else? So let's just say hypothetically that if a line has a slope of 2/3, what's the perpendicular line? What is its slope going to be?
2/3.
No.
Negative. The perpendicular.
It's going to be negative, but it's not negative 2/3. It's negative 3 over 2. So we do 2 things. We're going to change the sign, and we're going to flip the fraction. Okay, and that's summarized for you if you look on here. Let me find this thing.
Did I say switch and flip? Like Mr. Morioka said that.
Switch and flip.
Yeah.
That's it. Switch meaning switch the sign? Yep, I like that. Switch and flip. So there it is right there, right? Perpendicular lines have opposite reciprocal slopes. Opposite means change the sign. So if it's positive to negative, negative to positive, reciprocal means you flip the fraction. Okay? All right, so let's go to, and that's on your handout. So let's go to this one then. Let's do a problem like this. Think what we're doing here. We want to write an equation, so the line that we're going to build, in math we call this writing a line, right? When we write the equation of a line. So the one we're going to write is going to be yellow. That's our line. Write an equation in slope-intercept form for the line that passes through. So our point's going to go through that or our line's going to go through that point. Call it a yellow point because it's on the yellow line, right? It's going to be parallel to some other line. Let's make it an orange line. So this is the other line right there, but it's parallel to that, right? So what are we going to do? Okay, we need two parts to this, don't we? Let's take a quick look. If I just have, like, let's say I have the line y equals 2x minus 1. Okay, let's just think for a second, and you got to really put yourself in this mindset. You got to really focus on this and try to see if everything can fall into place. When I have the equation of a line like this is what we call an equation in two variables, right? It's got x's and y's in it, right? So a solution of, we talked a little bit about this yesterday, a solution of an equation in two variables has to have a value for each variable, right? So a solution is something that's going to make it true, right? Like, for example, x equals 1, y equals 1 is a solution because if I plug 1 in for x and 1 in for y, I get 1 equals 2 times 1 minus 1, which is true, isn't it? Agreed? So that works. So does the point x equals 2, y equals 3 if I plug that in. I get 3 equals 2 times 2 minus 1. Also true, right? Now, the thing that's really, I think, interesting about this, and some things will come together for you here in the past that you may have thought of as different concepts. Those are points on the line then, aren't they? If you think about what this is, this equation up here, it's a function, right? It's the recipe for creating all the points, all of the infinite points that make up that line. It's like a string of beads, right? And each bead corresponds to a point, okay? I could pick any x value because wouldn't you agree, if I extend this line forever, if an ant's walking along this line, if he's walking to the right, he's going uphill, right? But he could go, there's no limit to how far he goes. If he walks far enough up this line, is he ever going to get to an x coordinate of 1 billion? Yeah. It's going to be way up there, right? But he's going to get there, right? He's going to be really high up the line when he does that. Could he get to a quadrillion? Yeah, there's no limit. He could get to every possible positive number, couldn't he? He could also go backwards and get to every possible negative x coordinate, right? For every one of those x coordinates, there's only going to be a single y coordinate that puts him on the line, though. Agreed? We can pick an x coordinate at random. Let's just say we pick like 1 billion. Well, if I put 1 billion in for x, I'm going to calculate the y value that goes with that. I would get 2 times 1 billion is 2 billion minus 1, right? So what, 1 billion, 999 million, 999, blah, 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 et cetera, right? We could find the y value if we wanted to and make an ordered pair out of it, right? It doesn't work for all. There are some points, though, that don't fit that equation. Like, for example, if I try to put in the point -2, +3, it doesn't work. If I put in -2, I'm going to get -4 minus 1. I get back an answer of -5 for y, not 3. So that's a point that is not on the line. Okay, it's not a solution. Make sense? Okay? All right, so, oops, wrong way. This way. So then we know that this is a point that's on our line, and so it's an x and y value that is a solution. It is guaranteed to work for our equation, whatever that is, right? If I'm trying to write our equation in slope-intercept form, that's just going to be in the form y equals mx plus b, right? What are the two numbers I have to be able to plug in to specify our line?
4 and -3.
Well, okay, I mean, that's a point on our line. But to get our line, like if we look at this one here, there's a bunch of different x and y values that'll work in this equation. X can vary and y can vary depending on where the ant is on the line. But if you look at this equation, there's two numbers up there that are parameters of the line. It's like we're dialing in some values that make it one line.
2 and 1?
Yeah, 2 and -1, right? The slope and the y-intercept. I've got to specify, if I tweak those, like if I change the slope, this line's going to tilt up, isn't it? If I increase the y-intercept, it's going to slide up this way, isn't it? Right? So by controlling those two dials, we can dial in the exact line that we need. Agreed? So in our problem here, I've got to be able to fill in the blanks for our particular line that we're trying to write. The numbers I'm trying to plug in are the slope and the y-intercept, right? I need to be able to plug both those in. Agreed? Once I can plug in those numbers, I'm done. How am I going to get the slope? This comes from this additional information, right? We know that our line goes through this point, and it's parallel to this line, the orange line. So would you agree, here's our strategy then. If I could find the slope of the orange line, and the yellow line is parallel to it, same slope, right? What is the slope of the orange line? -7/4, because it's the number in front of x, isn't it? It's the coefficient of x. So this is telling us that the orange slope is -7/4. Well, then that's got to be our slope too, right? That's the yellow slope. So that's one of the two things I've got to answer. Now, if I could just figure out what b equals, I'd be set, right? So how could I do that? Well, I could plug this value in, and that's going to give me y equals -7/4 x plus b. To solve for b, you guys have done this a lot in Algebra 1. To solve for b, I could borrow this x and y value because it's a solution. Has to be. It's a point on the yellow line, so it's an x and y value that's guaranteed to work, right? So I could plug in -3 for y and +4 for x, and then if I plug in all those numbers, I can isolate b and get its value, right? So what's that look like if we do that? I'd get -3 equals -7/4 times 4/1 plus b, right? Well, let's simplify this. If I multiply these fractions, what happens? Good, I can cross-cancel, can't I? Right? When I multiply, I can cross-cancel. So I just end up getting then -3 equals, just be an equal sign, -7 plus b. What do I do to get the b by itself? Add 7. And I end up with, yeah. So there's the other part, right? If I combine both of those pieces of information, I've got the equation of the line then, don't I? Now I can't, here's the thing, sometimes people do this. Sometimes then they say, okay, well, if I plug that back in, I'm just going to get -3 equals, right? But you have to, you only borrow the x and y values. If we want to write the equation of the line, I have to write it in the form y equals mx plus b, where x and y are variables. But now I know the values of the slope and the y-intercept, right? So this becomes then, y equals -7/4 x, what is that, 4? Can't read my own writing, plus 4. That's our answer, right? Did it matter what the y-intercept was of this line? No, didn't make any difference, right? The y-intercept could be anything, but for the lines to be parallel, we had to have the same slope, right? So really all we needed from the orange line was its slope so that we could find out what our slope was. Make sense? Okay? So let's do one more of those. How about something like that? Stare at that for a second. See if you can come up with a strategy. So we're going to try to write a yellow line, but we're also given some information about some other orange line. So we want to get to this point. We want to get to the point where we can say, y equals mx plus b, and I can plug in those numbers, right? Okay, what you thinking here? Do we know a point that our line goes through? Which point does our yellow line pass through, based on that question?
5 and 10.
5 and 10, yeah, right. So this is our line. This is a yellow line, our yellow point, right? The orange line, they don't give us the equation of the line this time. They're just telling us that we're perpendicular to this other line that goes through those 2 points, right? So how could I take advantage of the fact that I know the orange points?
You have to do the opposite, right?
the slope, right?
The opposite of that then.
Okay, so the slope has to be an opposite reciprocal, right? So switch and flip, right? But I don't know the slope yet of the orange line. If I knew it, I could find the yellow slope, couldn't I? But I can find it because I know 2 points. 2 points define a slope, right? So looking at these 2 points, not that this is that big a deal, but which of these 2 points should be point 1 and which should be point 2? Look at the x values, -3 and 15. Which one is a greater x value? 15 or -3? 15, so that must be further to the right then, right? Because the x value is bigger. So we'll call this one point 2, and the one that's on the left we'll call point 1, how about? So now let's find the orange slope. The orange slope is just going to be y2 minus y1 over x2 minus x1. That's our formula, right? So what's that going to give us then for numbers? What minus what on top? Minus -4, good, over
15 minus -3.
Okay, so if we simplify that, subtracting a negative is like adding, right? So what's -14 plus 4?
10.
Oh,
Negative.
-10, okay. -10 over 15 plus 3, and what's that reduced to? Negative 5 times, yeah. If I divide both by 2, right? So there's our orange slope. What does that tell us about our yellow slope, though?
9/5.
Okay, good. They're perpendicular, so they have to flip and switch, right? Or switch and flip.
So does that mean that one's a positive number?
So, right. So it's going to be, so our slope is going to be positive 9/5, right? All we have to do now is figure out what b is. But that's the same strategy as before. Now we know our slope, we know an x and y value that work for us, because that's a point on the yellow line. So to find b, all we've got to do is plug in everything except b, right? So we know the slope is 9/5. We could plug in 5 for x and 10 for y, right? So that's going to give us 10 equals, what was it, 9/5? 9/5 for m times 5, I think it was. Isn't it? Yeah, 5 is my x value. Okay. Plus b, and I can cross cancel. Good. So I get 10 equals 9 plus b. So what's b? 1. If I subtract 9 from both sides, everybody agree? So b equals 1. And so now I can take these ingredients, now that I know m and b, and I can write the slope-intercept form of the line. Y equals what? 9/5 x plus 1. Agree? Okay? No big deal, right? We can do that. Okay. Last issue. I'm gonna go through this. Rather than have you guys practice, take time to go through one of those, what I think I'm going to do instead is go through a quick example or two of this and then get the Chromebooks and let you work on this assignment. Have you do a couple problems from this assignment to make sure you understand it, okay? So, graphing solutions to linear inequalities. You guys know how to do this. You've done this before, guaranteed. I just want to remind you what the rules are. It's not a big deal. Okay, so what would happen if I were to graph just the line, let's ignore the inequality for a second. What if I turn that into an equation? Y equals -4x minus 3. That's an easy one to graph. What's it look like? Where's the y-intercept? -3, so right there. And I guess I got to go down a little further, huh? And then my slope is, I'm going to rise by -4, you agree? And run by how much? 1, yeah, because -4 is the same as -4 over 1, right? So I rise by 1, 2, 3, one more, by -4, and I run by positive 1. So there's my other point right there. Okay? So those are the 2 points that I could connect and extend to make this line, right? But we're not graphing a line. We're graphing an inequality, right? So what does it mean to be an inequality? Well, now I want all the y values that are going to be less than or equal to that line. Does that make sense? Okay, so what is the graph of an inequality always going to look like? Well, it's always going to have the boundary line, and then we're going to shade either above or below that boundary line, right? Does that make sense? Okay. Now, in this case, this says y is less than or equal to. Well, y equals negative 4x minus 3 is the line. So the line, the boundary line, is included in the part that I'm going to graph, right? Do you remember that that means I'm going to make a solid line, right? What if it had just been like y is less than? Then the line is just the boundary, but it's not included. Does that make sense? What kind of line would I make then?
Dash.
Dash line, right? Just to indicate that it's just a boundary, but it's not part of the graph, the solution, right? But in this case, I am going to include the line, and it looks like, roughly like that, right? So there's the line part. Now the inequality part, the less than or greater than part. That means I'm always going to shade either this side or this side, right? Those are called half planes. This whole thing is the plane, and this is one half plane, and that's the other. They're infinitely big, right? Which one do I shade? Do you know? There is a trick. If it's written in slope-intercept form like this, if I'm taking the y values that are less than the line, which direction do you think I shade? Negative. Well, I'm going to shade down then, right? Because this is the y-axis. That's the positive y direction, isn't it? So if I want to take bigger y values, I'm going to go upwards. Lesser y values are going to go downwards. So because I'm taking the y values that are less than this boundary line, I'm going to shade everything down there, right? You get the idea? Okay, there's another way to do that. There's another way to test that. We could pick a test point that's not on the line. Like, let's say, for example, I'm going to pick the point, an easy one. I'm going to pick the point 0, 0. Okay, what's going to happen if 0, 0 is a part of the solution? Then we know what solutions are. Then that means that 0, 0 must satisfy or make true the original inequality, right? Let's plug it in and just see if it works. If I plug 0, 0 into this equation, what do I get? Well, I would get, I'm going to plug in 0 for y, so I would get 0 is less than or equal to negative 4 times 0, because I'm plugging in 0 for x, minus 3. So on the left side I get 0, on the right side I get negative 3. Is 0 less than or equal to negative 3? No, that's false, isn't it? Right? So if that's false, then that means that this point right here is not shaded. So if the test point that I pick is false, I'm going to shade the other side of the line. You get that? Okay? But once again, if it's in slope-intercept form, if the y is by itself, we don't even have to do that. We can just say if it's y is less than mx plus b, I'm shading below. If y is greater than, I'm shading above. Make sense? Okay, let's do one more of these with a line that's not in slope-intercept form. Okay, this time we would have to test a point, wouldn't we? Or put it into slope-intercept form. But I would say that it's probably harder to put it into slope-intercept form. There's more of a chance of a mistake, because I've got to multiply both sides by a negative and remember to flip the sign and everything. You could do it. It would work. But this might be an example where it's easier to just pick a test point. Okay, let's try one more of these, and then I'm done for the day and you can work. Okay, so if we want to graph the boundary line, right, the boundary line is going to be the equation. Okay, so we're just going to we're going to replace to get the boundary, we're just going to take that inequality and make it an equal sign. So 2x minus y equals 1. What was our trick for graphing a line in standard form? Remember, all we need are 2 points, right? Remember the trick? The cover-up trick?
Make one side equal the other.
Say it again.
Make one side equal the other.
Well, I mean, I don't know if that's, I don't think that's what I'm getting at. We just need 2 points. Let's pick easy ones. Let's pick the intercepts, right? If I want to find the y-intercept for this line, what value do I plug in for x? 0. Yeah. So if I plug in 0 for x, what's the y value I'm going to get? Well, let's find out. If x equals 0, then that term goes away, right? Solve the equation. Negative y equals 1, so what's y? Negative 1. I could multiply or divide both sides by negative 1, right? So I get the point 0, negative 1. So right there is a point on our boundary line, right? If I want to find the x-intercept, what do I let equal 0? Y. So I'll cover up y and solve. 2x equals 1. What's that give? If I solve for x, what's that give me?
1/2.
1/2. Okay? So that's the point right there, right? Make sense? Okay, so do I connect those with a solid or dashed line in this case? It can be dashed, right? Good, because I'm not including the equal sign in my inequality, right? So we have a boundary line that's not a part of the solution, it's just the boundary between the graph part and the shaded part and the unshaded part, right? Okay, so now what? We got to know which side to shade. Well, maybe. It's kind of hard to see by looking at it, but we could just test a point, couldn't we?
Yes.
Now, it's got to be a point that's not on the line, right? So would you agree that 0, 0 is not on the line? That's an easy one to check. Let's try that one. So we'll test 0, 0. So that's going to give us 2 times 0 minus 0 is less than 1. So 0 minus 0 is 0. Is 0 less than 1?
Yeah.
It is. Check, right? So then that means we're going to shade the test point pass, right? It made the inequality true, so it satisfied the inequality, so it's part of the solution then, right? So we'll shade that side, right? Make sense? We good with that? Okay, I want you to try this. Let me see, I think we can get Chromebooks. Let me go. Why don't you guys, just come with me, we'll just grab one. You can just grab one.
Oh, it's yours?
All right, grab, there you go.